So, as always, the code for this question will be in the description, but if you want the explanation, you can continue watching this video. See, the thing is, I like this question a lot because you might think that there is one approach, a really lengthy approach, which uses DP, recursion, all that, and this, the actual approach, the actual solution, easy solution for this can be solved with O of 1. You literally can solve it with O of 1 time complexity. See, I'll tell you how this thing goes, but before I get into it, let's explain this question first. You'll be given f of 1, which is x, and f of 2, which is y. Basically, the inputs you'll be given is x and y. You'll also be given another n. Now, what is n? But before, wait, you'll be given three inputs, first x and y, and then n. Now, it will be stated, it's stated that f of 1 is x, and f of 2 is y, right? And if you want to find f of n, in this case n is given, but if you want to find f of n is equals to f of n minus 1 plus f of n plus 1. This is an important point here. If you want to find f of, for example, let's take 3. It will be f of 2, which we know, y, plus f of 4. And for f of 4, again we put it here, we'll get f of 3 plus f of 5. For f of 5, it will be f of 4 plus f of 6. F of 6, 4, 5 and 7. So you see that if in order to get this one, you need to, in order to get this one, you need this one. Now, first things first, if you look at the test case, they explain it to you. Basically, in order to get over this solution, what you're supposed to do is take n plus 1 as n. N plus 1 will become n how? If we subtract it by 1, right? If we subtract the value of n by 1, if we convert n, which basically means that if n becomes n minus 1, what will happen? We'll have f of n minus 1 is equals to f of n minus 2 plus f of n. And we have f of n, we can put it here, we'll get is equals to f of n minus 1 minus f of n minus 2. So with this one, this is clear. The confusion, if anything was there, f of n, now we can find it out, which is f of n minus 1 minus f of n minus 2. The problem here is, let's take they gave you f of n is 1000, some value. Even though the n value they gave in the question is bigger. I think it's 10 power 6 or 10 power 12 something. Let's take 1000. F of 1000 is f of 999 minus f of 998. And f of 999, just that one comparison, is f of 998 minus f of 997. And f of 998 will again be f of 987 minus f of 986. For just one thing, you have to go through a whole stack. Now, you might think, okay, recursion is the first thing. The first problem you'll get is stack depth will be exceeded. Time, okay, maybe it will work or not. No, it won't work, but for some reason your program runs so fast that you can run this thing. The stack depth will exceed because it's 10 power 12. How long will the stack be? DP, you might think it will work, but it won't, because again, it's a stack thing. The stack depth doesn't depend on DP, even though you have to go through the stack. The computation is saved by DP. DP just saves the computation time. The stack depth is still the same for both of them. So in that case, it's not working. If you wondered, you can write a recursion solution. It's easy, but it won't work. That's it. You want to accept it there. You don't want that solution which works properly. You want the accepted thing, the green color thing, the green color dopamine that you'll get. Okay. What do you do now? See, in conditions like these, what I'll tell you is, whenever you're given these conditions, sometimes for some reason, it's best to look at the pattern they're following. And usually that's going to give you a hint, but in this case, it gave me the answer itself, which is, let me tell you. Okay, so see, as you can see, I do this table here and this formula that we have. So basically, f of n is f of n minus 1 minus f of n minus 2. And you know f of 1 and f of 2 is x and y, which they'll give us. According to this equation, if you what I'll get is f of 3 is f of 2 minus f of 1, which is y minus x. Okay. And f of 4 is f of 3 minus f of 2, which is minus x. Because y minus x minus y is x minus x. And f of 5 is 4 minus 3, which means what will you get? Minus y. Right, minus y plus x plus a minus x will be cancelled. You will get minus y. And f of 6 is 5 minus 4. 5 minus 4 is minus y plus x. And now f of 7 is 6 minus 5, which is what will you get? X. And f of 8, if you look at this thing, f of 7 is x, which we got here. Note that thing. F of 8 is this minus this again, right? Which means x minus of minus y plus y and minus x, which means we will get y. And 9 at this point is this. And 10 will be minus x. And 11 will be minus y. And 12 will be minus y plus x. 13 will be x again. And 14 will be, get my point basically, right? This is our sequence. This sequence from 1 to 6 will keep repeating no matter how many times what the number might be. If you take a number, you modulo it by 6, you get the answer. Basically, that's what they're trying. That's what the question is. To be specific, what you have to do is take all of these things that you have. I mean, not things. Take all of these variables that you have into an array. You can take the array as for 0. In this case, it will be 1, 2, 3, 4, 5, 6. But in that case, what you can do is, I'll tell you what. First, you store these in an array. X, y minus x, minus x, minus y plus x. Store these values in an array first. What you will do is, now since these keep repeating, whatever number you get, you modulo it by 6 and you get to the same thing. 6 modulo 12 is again this same value, right? So what you'll get is, take these values and you modulate it, you get the point. I mean, you'll get the occurrence. Which occurrence does it come under? So, for example, it comes under this. But it's 3, right? In arrays, it will be indexed as this 0, 1, 2, 3, 4, 5. So, what you simply have to do is subtract 1 from it. You get modulo the number by 6. You'll get some value, which is, for example, in this case, you'll get 3 or something. You just subtract it by 1. You'll get 2, which is the index of that particular value in the array. And that is the exact answer you'll get. That's it. Take this answer, print it, because you have y and n, x. So n modulo 6 minus 1 is, if you get this answer, this y minus x will be the answer. Whatever y and x are, it will get the answer. And they ask you to modulate by, if you look at it, the funny trick part is, these numbers won't be that big. I mean, usually. I mean, they will be, but since it's not like it's some kind of an increasing sequence. The way sequence the sequence has a sequence. Basically, the numbers won't keep increasing. It stays the same. But what they gave you is 10 power 9 plus 7. Plus 7. That's what they told you. Plus 7. There's 7 with the 7th occurrence, it changes. So that's a nice point. I don't know how it correlates in terms of modulo. My modulo, how do I say this? My knowledge in modulus is not as good as I would like to admit. So I just assume that I know what I'm talking about. But yeah, when it comes to the code, this is the code. And you modulate by whatever they ask you to give there. The only thing is sometimes you think something is pretty complicated and all, but it doesn't take a lot to just put that idea aside and think about a new idea for 5 minutes. You might get an idea like this. And usually when functions like this come up, it's best to write down a few iterations to see if there is a pattern or something like that. So yeah, this is an easy question, even though it was pretty high rated. I'm not as high, but for me it was. So yeah, that's it. That's how to solve this thing. The code is in the description, and thank you.